Hi everybody, I'm Dave Vaillancourt. I work for ESRI in the Colorado office here down in Brookfield. I want to talk to you today about spatial thinking and how you can use spatial thinking to solve geographic problems. Many of us work for organizations where our job is to solve some kind of a geographic problem, a problem in general. Many of these are geographic in nature. We use a lot of fancy tools, but do you ever stop and think about where you got those skills? Where you learned how to think in space and time? I think a lot of these came from our early childhood development. The first thing we learn when we're growing up is place, where I am. I'm in the kitchen, in the backyard, at grandma's house. Next thing you learn is navigation, how to get to places. If you were a delinquent like me, you were interested in where the cops were and how to get away from them. The third thing we learn is patterns. And patterns are a little bit more abstract and take more time to learn. This is where we really start thinking about geography. Does anybody see any patterns in this map? A couple of them, maybe some of you see some, maybe some of you don't. The types of patterns I'm talking about really are like proximity, scale, connectivity, navigation, that kind of thing. So let's now move to an early example of geographic spatial thought. Back in the 1850s in London, people were sick with cholera. And there was a lot of confusion over where this was coming from. This is an early map built by Dr. John Snow, and all the red dots are places where people died of cholera. And all the blue locations are the pumps from where these people were getting their water. At the time, he saw some definite pattern in this map. And what he did was he used his own mental spatial analysis to determine that this pump right here, if they shut that down, they would save lives, and they did. We can use more fancy tools today, get the same results, but really it's the pattern of thought we're after, not the advanced geoprocessing tools we're using. Let's move on to navigation. So once you learn place, you learn to navigate. Here in this example in Washington, D.C., I've got a bookstore, or rather a warehouse right here, and I'm going to deliver books by car to all these bookstores on the map. What do you think will be the easiest route, the shortest route to get there? It's not that hard to determine. You can pretty much make a big loop around the city to get back. Go to each one of those stores and come back to the warehouse at the end of the day. But the real world is more complex. What if we introduce time to the equation? We have time windows for all these bookstores. For example, down here in the blue, do you think you'd take the same route? Take a second and look at that.
No.
Yes, no? Probably not, right? When you have these time windows, you have, in addition to the spatial constraints, you have time constraints. We use a GIS and solve this in just a couple of seconds. But really, you can see the optimized route is much more complicated. But in the end, we've got a shorter route, less fuel, less expense, less carbon, and so on. Now let's move on to another example. For over 30 years, there's this guy in Norway called the Pocket Man who is a terrible sexual offender, and he is linked to 300 to 400 cases of this bad activity. So let's talk about how we could use the geographic approach to solve this problem. Here's a map of Norway, and it has all the incidents over this time period. I want you to look at this first and see if you see any patterns or trends. You guys see anything? Some stuff? Excellent. I think you all noticed probably there's some spatial clustering around a couple of cities, Bergen and Oslo. So that's pretty obvious to see it's a spatial clustering. Some of you might think we also need to include time in our equation, understanding time. Is time relevant? If we look here, I know it's hard to see, but we've got yellow dots indicating the early events. You'll notice definite spatial clustering around those two cities. So perhaps we're talking about somebody who lives in Bergen, or lives in Oslo, or moved from one location to the other. As we move forward in time and look at the middle events, we'll see a different pattern, right? There's a lot more going on, a lot more along the roadways. So we're probably talking about someone who's got a car, someone who's traveling. Maybe their job is driving a truck. Towards the end, if we look at those observations, you'll notice that they're much more random. Is this someone who's trying to deceive the police to make it harder for them to track? By now, this has been 20 years they've been looking for this guy, so he's probably looking to hide himself even further. Some of you might also think that in addition to time, we should consider the day of the week in our analysis. If you look at the early events in yellow, you'll see no pattern, but as you look at the later events, you'll see more commonly they happen on weekends. So we're probably talking about somebody who's got to use a car to drive away to get to their place, to do their bad things. In the end, just as we suspected, they caught the perpetrator after 30 years in 2008, and he lived just three kilometers from the mean center of the early attacks, here right in the middle of all these locations. So this is an example of how using the geographic approach you could help solve a problem, help catch someone bad. I hope no matter what your job is, you start thinking about thinking spatially and how you use spatial thought, and how you use your spatial understanding to do your job. In the end, when you got to solve problems, I think you'll be more effective taking into account that spatial context. Thanks.